Hey boys and girls, today is math lesson 112 and I have a treat for you. I have the answer to your riddle, okay, which unfortunately I forgot to mention yesterday. So the riddle that you guys had on Monday with the investigation this is what it was. It was a fun one. A duck was given $9, a spider was given $36, a bee was given $27. Based off that information, how much money would be given to the cat? Okay, so to figure that out, it was $18, okay, because you get $4.50 for each leg. Okay, $4.50 for each leg. Kind of a fun one. Try to figure that out and be stumped. Okay. At the end of today's lesson, I will give you a new riddle about a rooster laying some eggs. So you might want to pay attention and watch the whole video, or not just go to the end because maybe it will be in the middle. So don't just fast forward for the end. It'll be somewhere in the video. So hopefully you watch the whole video to figure that out. Here we go. We're going to jump into a lesson I've already taught you because I'm such an amazing teacher. Okay, and you knew that, right? No, I'm just kidding. We are supposed to be humble, right? But I taught this lesson to you already, and you just didn't know it. It's called reducing fractions. Okay, so last week when we were learning about fractions and the fraction name for one whole, okay, when we had this big number 1, and then we did something like that, okay, and then inside of that number 1 we put a fraction name, anything, 3 over 3, 4 over 4, 1 million over 1 million, anything over itself, it's a division problem. 3 divided by 3 is 1, okay? So as long as we take anything times itself, times 1, okay, we're going to get the same answer, right? So 3 times 1 is 3. 100 times 1 is 100. That's the identity property of multiplication. Okay, so the same thing works even when we're multiplying fractions, and we learned that last week. If we multiplied 9/15 times 1, okay, if I did that times 1, I'm going to get times 1 equals 9/15. Well, what does that look like? If I take 3/3, okay, I take it times 3 times 3. 3 over 3 is the same as 1, okay? And 9 times 3 is 27. 15 times 3 is 45, okay? And we learned that 9/15 is the same. Those two are equal. They are equivalent fractions. That's that cool word, okay? Equivalent, okay? Equivalent. That means equal, okay? So we're going to come back to that problem after I show you a few other things. What we're doing now today is reduce. We are going to reduce fractions, okay? So this is how we made a fraction that was equal to it. We multiplied it by 3. Now we're going to do something a little bit different, and I've already shown you how these things go back and forth, so this will be review it to a little bit of an extent, okay? So now, let's just say 4/6, okay? Could I make that smaller, reduce it to something smaller? To think back to something we did in class back when we were together, okay? We played with fraction manipulatives, and they were just circles, okay? And we learned that if we had the 1/2 piece, okay, we could trade that out for 2 1/4, okay? So that means, okay, 2/4 was equal to 1/2, okay? Because I can have 2/4, okay? 2/4, I should have used a color there, is the same as 1/2, okay? Actually, I think I will, so that you guys can see that more clearly, okay? And there's 1 2, okay? There's 2/4, okay? That's the same as 1/2, okay? So how did we get from 2/4 to 1/2, okay? Well, okay, if we have 2/4, we can divide by 2 and 2, and that equals 1/2. We can also go from 1/2 and multiply by 2, and we get 1 times 2 is 2, 2 times 2 is 4, so 2/4, 1/2 equals 2/4, or 2/4 equals 1/2. That is the exact same thing. We talked about that last week when we were making fractions equivalent fractions, okay? And so as long as we're multiplying by 1, okay, remember this right here is really multiplying by 1 because 2 over 2 is equal to 1 whole, okay? And that should be locked in from last week and make sense, okay? So now as we proceed through here, okay, we're just simply, well, another thing I can say, inverse operations, okay, if I'm driving towards addition in the classroom, addition's on that wall, and I want to undo it, I want to reverse it, but it's not reverse in math, it's inverse, put it in inverse. I was going towards addition, what do I got to have? That's right, subtraction. Beep, beep, subtraction. Beep, beep, subtraction. Make sure you look over your shoulder. Beep, beep, subtraction. Okay? But now what if I'm doing the opposite? So addition and subtraction, they undo each other. Okay? So we knew that when we had 3 plus 2 equals 5. Okay, right? And suddenly if I don't know 2, and that's A, okay, I can do, okay, A equals, what is that? Okay, I can do subtraction to undo that. 5 minus 3 is 2, so A equals 2. If I plug and check that in there, plug it in, okay, and then we get 2, okay, 3 plus 2 does equal 5, okay, so addition and subtraction, they undo each other. They're inverse operations, okay. Now what's inverse operation of multiplication? I'm driving towards multiplication. Multiplication. Oh, I need to undo it. And put it in inverse division. Beep, beep, division. Beep, 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 division. Okay, so I can undo multiplication with division and division with multiplication. Okay, so that's what's going on here. Okay, so now I'm going to erase all this. Okay, and we're going to get to the problems that are on the board. Okay, and these are all problems we're going to work through. Okay. So if I take 4, 6, I gotta find a number, I want to make it smaller, that I can, and some fractions can be reduced and some can't, okay? So I gotta find a number that I can, the same number, okay, that I can divide out of both of them. Why does it have to be the same number? Because if I did divide by 2 here and divide by 3 here, is 2/3 equal to 1? Am I dividing that by 1? I'm not. Okay, so I need to either divide by 1 or multiply by 1, okay? And so I gotta make it equal to 1. So that doesn't work, okay? I can't have two different numbers. Whatever I do to the top, I gotta do the bottom, or whatever I do to the bottom, I gotta do the top. You gotta think about it like that. So what number can I take out of both those? Fun fact, okay? If you have two even numbers, you can always take out a 2, okay? 2 and 2, okay? Sometimes if you take out a 2, you might have to keep going, okay? But here, so this is 4 divided by 2 equals 2. 6 divided by 2 equals 3. Okay, so 4, 6 reduces to 2/3. 4, 6 equals 2/3. That's how you do that. Okay, so you divide by 2, divide by 2. Okay, now to go the other way, we could go the other way, and we could figure out that we'd multiply, okay, by 2 going this direction, and multiply by 2 going this direction, and get 6, okay? They undo each other, okay? So the inverse, okay? But what you're going to do today, when they say reduce the fraction, you're doing 4, 6 equals 2/3. 2/3 is your answer, okay? I'm going to sidetrack it. Actually, I'm going to wait with sidetracking it up there. 3, 6. What could you divide out of 3 and 6? Okay. Another fun tip is to see, can the small number go into the big number evenly? And if it can, that's going to be the best thing that you can do, and it will get it to the lowest fraction that you can possibly get right away. So does 3 go into 6? It sure does. Okay, so I can divide by 3, which is really saying dividing by 1, because 3 over 3 is 1. 3 divided by 3 is 1, which equals 1. 6 divided by 3 is 2. Okay, so 3/6 is the same as 1/2. And some of you knew that right away, because 3 is half of 6. Half. Okay? So pretty fun. 3/15. What can I do? 3 divided, no, well, it would be 3. That's how you would figure out that as a decimal. But what can come out of 3 and 15? Remember I said, if you can take the small number and it can go evenly into the big number, you can use that as your number to divide by. So does 3 go into 15 evenly? It sure does. This is why knowing your multiplication facts, lickety split, being a math master. A what? A what? A math master. Okay. You can instantly see right away, oh, I need to take a 3 out of that. So 3 divided by 3 is 1. 15 divided by 3 is 5. So 3/15 is the same as 1/5. 3/15 reduces to 1/5. Okay, 9/12. Start away. Does 9 go into 12? Oh, no, it doesn't. No, what do I do? I don't know what to do. I don't know my multiplication facts. Well, then learn your multiplication facts. Okay, but you go through your multiplication facts and you say, okay, how can I get to 9? What other factors can come out of 9? This is where you're factoring, okay? So the factors of 9, okay, are 1 times 9 and 3 times 3. So the factors of 9 are 1, 3, and 9. The factors of 12 are, okay, 12 are 1 times 12, 2 times 6, and 3 times 4, okay? Now you have to have a common factor, and you want to have the greatest common factor, the biggest, okay? So you can go through here and you can see, okay, 1, yeah, they both have a 1, okay? They both have a 1, but that wouldn't change anything, okay? So get rid of the 1, okay? Do they both have a 3? Well, they do. They both have a 3. Do they both have a 9? No, I figured it out because 9 can't go into 12. They do not both have a 9, okay? So 9 goes away. So that's all the factors of 3. So it has to be divide by 3, divide by 3. And many of you could do that in your head right away. Divide by 3 and 3, which, refresher, 3 over 3 is the same as 1. Okay, so 9 divided by 3 equals 3. 12 divided by 3 equals 4. Okay, so 9/12 is the same as 3/4. It's this equivalent, okay? Now I could go back the other direction, okay, to show that to you as well, okay? Oopsies, I erased that and I didn't want to, okay? 3/4. So if I started at 3/4, okay, and I wanted to make an equivalent fraction, I could just multiply the same number by 3 and 3, and I get 9/12. 3 times 3 is 9, 4 times 3 is 12. So that's the same thing. They inverse, they undo each other, okay? So, answer reduced is 3/4, okay? Now, I'm going to jump over here. 7/8, okay? I think I told you, my shadow's in the way there. It's in the way there too. The lighting down here is horrible. Okay, I think you can still see it with the shadow. There, now the shadow's not. 7/8, okay? Can 7 go into 8? No, can't go in evenly. Okay, can it go in evenly? That's the question I asked. So then you say, what are the factors of 7? Oh, 7's one of those special numbers, those prime numbers. All there is 1 and 7. There's nothing else. So 7/8 is as low as it goes. Done deal. Okay? Not all fractions can be reduced. Okay? So let's try 6/8. Okay? I start by saying, can 6 go into 8? Evenly? No, it cannot. Okay? So then I need to divide by. What can I take out of that? Oh, okay, 6. What else is there in 6? A 2. Okay? Oh no, let's do a 3. I'm going to divide by 3. Okay? 6 divided by 3 equals 2. 8 divided by 3 equals, it doesn't go in evenly. So right away I know I can't use a 3, because I gotta, whatever I do the top, I do the bottom, so I can't use a 3. Okay, so instead I gotta use a 2, because they're both even. Okay, so 6 divided by 2 is 3, 8 divided by 2 is 4, 6/8 and 3/4 are the same thing. Okay, and that's a fun one to see on your ruler. Okay, when we're talking about a ruler, there's halves. Okay, there's eighths. Okay, and we go to 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Okay, 6/8 right there is the same as 3/4, and that's what you would want to say is 3/4. You wouldn't want to say 6/8, okay, because 3/4 is an easier way to understand that fraction. Okay, now if I took away the eighth marks, okay, and we got rid of those, you would see, okay, that there's now 4 pieces. Okay, so this is 1/4, this is 2/4, this is 3/4, and this is 4/4. So it just changes it, and that's how they are reduced. Okay, now that's similar to 6/8 is the same as 3/4. It's not similar, it's exactly the same. Okay, so that's understanding it on a different application. And if you ever do any building of things, like Henry's dad, I know, has built some stuff. Malachi's dad, I've talked to them doing projects in your house. Parker's dad, okay, and Dex's dad, I don't know who all does kind of construction type stuff. Some people do it for a living, some of your parents do it for a living, and they use those fractions and they use these reducing fractions all the time when they're building stuff, okay? So it's really fun, okay? When I built this whole little board to teach down here, I had to use fractions and make sure I was marking things right to the right spot and being able to read the tape measure and to know was I doing 6/8 of an inch or 3/4. Wow, they're the same thing, but you would want to say 3/4. Okay, so we're reducing fractions. Okay, 6/7. Oh, I see that 7. If you see a prime number, okay, it's going to be as low as it can go because there's nothing that you can take out of it besides itself. Okay, so done deal. You can't take anything out of that. Okay, we already did 9/15. Okay, and now we didn't reduce it though. We actually made it bigger. But could we make 27/45 back into 9/15? Let's try that. 27/45 divide by, and I know, okay, that I took it by 3. What if I go by 3? 27 divided by 3 is 9. 45 divided by 3 is 15. Okay, so that does work. I can reduce 27/45 to 9/15. Okay, now let's say that I did that. Okay, and this now is gone. Okay, and that was your answer, and you said, "Oh, I'm good." Okay, well, wait a second. That's not as small as it can go. It can actually go smaller than that. Okay, so what do I do again? Some of you math masters, see right away, you can take a 3 out of both of those numbers. Divide by 3, divide by 3. Okay, and you have 9 divided by 3 equals 3. 15 divided by 3 equals 5. Okay, so 9/15 is the same as 3/5. Okay, so really 27/45 reduces to 3/5. That's how you figure that one out. 4/10. Does 4 go into 10? Nope. Okay, can't divide by 4. Okay, so I gotta find something else. They're both even. Divide by 2. Divide by 2 equals 4 divided by 2 is 2. 10 divided by 2 is 5. Answer is 2/5. Okay, so now I'm going to bring this to something fun. Okay, this equals, okay, and let's say this is a 2, okay, and this is a question mark, and you have to figure out what is the question mark. Okay, What is the question mark? Well, suddenly you figure that out by going, how do I get from 6 to 2? Well, I divide by 3. Whatever I do to the bottom, I do to the top. So 3 divided by 3 is 1. So question mark equals 1. Is that cool or what? Okay, I could do the same thing here on this one. Okay, if I have equals, okay, and then I have a question mark there. What's the question mark? How do I get from 15 to 5? Divide by 3. So whatever I do to the bottom, I do to the top, or vice versa. 3 divided by 3 is 1. So question mark equals 1. Okay? Those are fun as well, and those will be something that will build into being able to see when we add fractions with uncommon denominators eventually. So that's today's lesson. Hope you enjoyed it. Have fun reducing fractions.